Okay, students, today we will discuss integer overflow problem. Now, as you all know, in Turbo C, the range of integer is -32768 to +32767. Okay, and for unsigned integer, range is range is 0 to 65,535. This is for integer. And for character also, you have a range from -128. The characters are represented as ASCII value in C, so it has a range from -128 to +127, and unsigned character has a range from 0 to 255. Okay, and the storage for integer is 2 bytes, means an integer variable takes 2 bytes in memory, while a character variable takes 1 bytes in memory, whether it is signed or unsigned. Okay, now let us say that if I give a declaration like character ch, where ch is a character variable in C, and I assign value ch equals to 128, what will be stored in ch? And suppose I would need to print this ch with a printf statement like %c ch, what will be printed out? Now most of you will say that okay, 128 will be printed out, but let us understand the output of this printf statement will be -128. How did it become -128? When I tried 128, it should have been printed like this. How come that it is showing -128? Let us understand this and explore it a little further. Now, as I told you, the character has a range from -128 to +127. Means the value that we assigned to the character variable ch was outside the range. It was 128, means more than the positive range, means the positive side of the range. Now what does it do in that case? Now if you understand from the bit settings, as I told you, character takes 1 byte in memory. Now let us understand this through byte settings. 2, 3, 4, 5, 6, 7, 8. This is the bit string, means 1 byte of memory. Now when I assigned 128 to the character, then what does it takes? Let us try to write 128. This will be 0. 128 will be 2 raised to the power 2 raised to the power 6, 2 raised to the 6, 64, 2 raised to the power 7, 128. So 2 raised to the power 7 means 0, 0, 0, 0, 0, 0, 0, 1. Okay, this will be stored in 1 byte. Okay, this is 128. Now if you understand this is 128. Okay, it's showing it that 128. Now if you understand -128, let us store -128 in 1 byte. Let us see what will be -128. -128, since it is a negative number, it will be stored like this in 2's complement notation, because negative numbers are presented in 2's complement notation. So what will be the value -128? Let us see its magnitude. Its magnitude will be 100, means the same as we have written on this side, 100, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5. So this is the magnitude of -128, and if I take 1's complement, it will be 0, 1, 1, 1, 1, 1, 1, 1. Okay, this is in 1's complement, and if I add 1 to it, it will be 0, 0, 0, 0, 0, 0, 0, 1. Okay, this will be this one. Okay, now what is this? It is the same value as written on the upper side. It means this is actually a representation of minus 128 in signed magnitude representation. Since it is a signed character, this value is minus 128 to plus 127. So when you try to give a value 128, it shows actually minus 128. Okay, and if you observe it very carefully, when you try to give a value uh, outside the range, means 127 is the last value on the positive side. So if you try to give a value on this positive side one more than this range 128, it accommodates, it tries to accommodate that value within that range, and in that attempt it takes it to the upper second other side of the range, so it shows minus 128. So if you take 129, it will show minus 127. That you can verify through this bit settings. Okay, and similarly, if you assign minus one, if you take minus 128, let us confirm this, that if you take minus 129, suppose the value is minus 29, that you are storing in a character variable, which is a signed character. So minus 129 in bit setting, what will be minus 129? Let us see. It will be minus 129 will be, let us represent its magnitude. Magnitude will be 128 0 0 0 0 0 1. This is magnitude. Add 1 to it, it will be 0 1 1, sorry, 0, next 1 0 0 0 0 0 1. Okay, this will be, and so this is the add, we have written 129, this is minus 129, let us correct it. This is minus, this is the magnitude of 129, takes one's complement of it, first takes one complement, it will be 0 1 1 1 1 1 1 0. Now add 1 to it, it will be, it will make it 1, it will make it 1, and it will remain 1 1 1 0. Okay. Okay. Now this will be the representation of minus 129. Now if you observe it, this minus 129 in positive side, if you, this is the representation of minus 29, this is actually equivalent to calculated 64 plus 32, 96, 96 plus 16, okay, plus just calculated, it will be equal to 1, it will be equal to 127. This is actually the value for 127, and which you can check that it is the other side of the range. Means when you try to give a value minus 129, you are suppressing this range, you are trying to give a value which is not accommodating within this range, and you trying to give a value to this character variable minus 129, so it is, does not give any error, it does not issues any warning, rather what it does, it takes it to the other side of the range, and in this attempt to take it to the other side of the range, it will show it as 127. That you can confirm through this bit settings. And if you give the value 130 minus 130, naturally it will take it to the other side of the range, so it will be shown as to be 126. Okay, the range will start and will go on decreasing from the other side. It cannot give a value outside this range, so it will take minus 129 to 127, minus 130 to 126, plus 126, minus 131 to plus 125, and so on. So ultimately it tries to accommodate the value within the range. So when you give a value below the negative range, it takes it to the positive side of the range, and if you take a value from the positive side of the range and try to give a value which is outside this positive range, it tries to give, it starts showing the value from the other side of the range, means the negative side of the range. Okay, so this is the main concept behind the integer overflow. And similarly, you can understand this through unsigned int also, or unsigned character also. As I told you, unsigned character has a range from 0 to 255. This is the range of the unsigned character. Now if I take a variable which is of unsigned nature, unsigned care, ch, and assign a value 256 to it. Now you would have guessed what value it will show. It will actually show the value 0 in ch. So when you try to print ch, through %d, means you want to print the ASCII value of this character, then the value that will be printed out will not be 256, it will be 0, as you might have guessed now, because 256 is a value which is outside this range, means that actually it is taking the unsigned representation, so it is shifting the negative side of the range to the positive side, and the range becomes 0 to 255 for unsigned character. And when you try to give a value which is outside 255, means 256, it shifts it to the other side of the range, means it shows the value 0. Similarly, if you try to store value 257, it will naturally show 1, and for 258 it will show 2. Okay, and similarly, if you want to give a value below this side of the range, means -1, then in value -1 it will show the value 255. Actually, the value that will be stored, if you assign it to be -1, the value that will be stored in this character will be 255. You can confirm through bit settings also. And when you try to give value -2, it will show 254, and so on. Means it will take the value from the other side of the range. So this is the main concept behind integer code. Okay. Thank you.